So here we're going to start looking at it more in-depth examples of the binomial distribution, something more representative of what you'll see on an exam or something. So here's example 3. I'm just continuing from the previous video. Pause the video and write this down. Alright, so in the U.S., 25% of all households are wireless only, no landlines. In a random sample of 20 households, find the following. So, what we want to do here first, though, is I guess I want to write an example first. A, the probability of exactly 5 households are wireless only. So that's what I want to find the probability of. And here we want to let capital X equal households, number of households, wireless only. Alright, so let's start off by writing it. Let's write our formula. We have the probability of X is equal to X. Capital X is equal to little x. Capital X is our random variable number of households. And so this capital X is always just a descriptor of what we're looking at. And then little x will be the number of households we're actually looking for. So let's write our formula. You should have this memorized, and if not, memorize it soon. Alright, so here in this example, I'm looking for the probability that capital X is equal to 5. So if you need to do a little side work to label what everything is, then go ahead. But we're going to continue here. N is the sample size, 20. X is the number of successes that we're looking for. And you just need to read the problem to figure out what X is. It says exactly 5 households. And it's also here, X is equal to 5. So it's telling you already what X is. And then P, the probability of a success, that a house is wireless only, that's 25%. So we will say 0.25 raised to the 5th power. And then 1 minus 0.25 raised to the n minus x power. So take it step by step and just let's simplify a couple things first. Let's say this is 20 combination 5, and this stays the same. And here we have 0.75 raised to the 15th power. So do the combination first, then multiply this, 0.25 to the 5th, and then multiply this, and you will get 0.2023, or 20% roughly. That's the probability of exactly 5 households, is 20%. Alright, let's keep going. The probability fewer than 3 are wireless only. Alright, and here you have to be careful of wording. It says fewer than 3. So we can start out by saying the probability that X is fewer than 3, meaning less than 3. Alright, but since we're dealing with a discrete distribution here, we don't need to count 3, and we don't need to count anything in between 2 and 3, because there's no such thing as 2.5 households or 2.3 households. So when we're dealing with discrete and we have a less than symbol like this, then we can change this to a less than or equal, and this becomes a 2 now. So we'll use this, you'll see this a lot, so make sure you're comfortable with what's going on here. maybe this will help. 0, 1, 2, 3, 4, and so on. So we were looking at strictly less than 3. So we were wanting to look at this area here, not counting 3. But there's nothing in between 2 and 3 here, so we would just want to strictly look at those numbers here. So just give that a little thought, but that's something that we will be using a bit. All right, and now it's plugging into our formula. Our formula is up here. I encourage you to write it every single time if you need it. So what does this mean? Probability that x is less than or equal to 2. That means we need to account for 0, 1, and 2. So what this is telling me now is that I need to find the probability that x is equal to 0, or x is equal to 1, or x is equal to 2. I should say and, not or. So we have to find all 3 of these probabilities now. We can break this up into probability that x is equal to 0, plus the probability that x is equal to 1, plus the probability that x is equal to 2. So now we have to do the binomial 3 times in this one problem. So this is going to take some time, so go slow and make sure you do it right. So worrying about x equals zeros first, we have 20, choose 0, and then the probability is 0.25 raised to the 0 times, I already know this is 0.75 from the previous problem, raised to the 20th, then plus. Now you try to finish the problem. You do x equals 1 and x equals 2, and then multiply it all together and come up with your answer. I'm going to go ahead and finish writing this out. And I ran out of room here. Alright, so this is equal to 0.0032 plus 0.0211 plus 0.0669, which is equal to 0.912. or 9.112% of the probability that there are 3 or fewer. All right, so this is looking at exactly one number. This is looking at multiple numbers when we're dealing with less than. And now we need to worry about what does greater than or equal look like here. So let's look at part C. The probability at least 3 are wireless only. Alright, now we need to be careful with wording here. At least, that means we want 3 or more. So we write that. The probability that x is greater than or equal to 3. That means 3 or more. Now, this is where it gets difficult, because if we were to do what we did on part B, where we wrote out every single number, so we'd have probability that x is equal to 3 plus the probability x is equal to 4 plus the probability x is equal to 5 all the way to probability x is equal to 20. We don't want to have to do this 17 times. So there is a workaround, and you will need to know how to do this. So what you do is you do 1 minus the probability of capital X is less than that number. And you want to make sure it's less than. Alright? And based on part B, we can change when we have less than to, we can change it to a less than or equal, but we have to lower that number. Alright? And you can work out the steps again if you want, but in part B we found the probability that x is less than or equal to 2, and that was 0.0912. So that equals 0.9088. or 90.88% would, at least 3 will be wireless only. So one more here. Part D, probability, the number of households that are wireless only is between 5 and 7 inclusively. So here, what are we asking for? How do we write this? That will be the first thing. So maybe just watch me if you're not familiar with this. So we want x to be between two values. So we're going to have numbers here and here. We want it to be between 5 and 7. So 5 and 7. And we want to make sure we include those numbers. So this is saying x is between 5 and 7, including those numbers. So we can write this out as the probability that x is equal to 5 and probability x is equal to 6 and x is equal to 7. And then we can break these out again just like we did previously. X is equal to 5 plus x is equal to 6 plus probability x is equal to 7. And now you have three more to compute here. So I'm just going to give you the answer and I'll let you work these out. Plus, so probability x is equal to 5 is 0.2023, x is equal to 6 is 0.1686 plus 0.1124, which is 0.4833. So the probability, the number of households that are wireless only between 5 and 7 is roughly 48%. Alright, so that covers this. Now what we want to get into is we want to look at the expected value and standard deviation. What we looked at in the previous chapter when we were talking about, previous section when we were talking about probability distributions. So here, expected value and standard deviation of a binomial random variable is. Alright, so we can you'll see this written mu sub x is the same thing as the expected value of x. So here is the expected value, which is equal to, and this is pretty simple, n, the total number of trials, times p. That is the expected value, or the expected outcome of our binomial random variable. And then we have the standard deviation, which is sigma sub x, representing this is the standard deviation of the random variable x. Just like here, this is saying the mean of the random variable x. That's equal to, now watch me for a second, it's similar to this one, it's just we have a couple things added. So we have this n times p, so it's the same thing so far. But so remember, p is the success, but now we want to multiply the probability of a failure, 1 minus p, and then square root all that. Alright, let's look at an example real quick of how to evaluate these. So, example 4. Let's see, 25% of homes are wireless only. A random sample of 300 is chosen. Let's say part A. find the expected value of x and the standard deviation of x. Alright, so let's start with e of x. That's equal to, write the formula, n times p, the total number of trials or the sample size times the probability of a success. So in this example, 300 is chosen as our sample. So we get 300 times p, the success, which is 25%, 0.25. Multiply that together and you get 75. That means out of these 300, we expect 75 of them to be wireless only. In part, nope. And then, so standard deviation of x is equal to, write the formula now, n times p, 1 minus p. So just plug in everything we know. Do the square roots here. N is 300, p is 0.25. That means 1 minus p, 1 minus 0.25 is 0.75, which is equal to 7.5. Alright, so now that we are given, now that we have a mean and a standard deviation, we can use the empirical rule here to take this a step further. So part B, use the empirical rule to determine if 92 homes are wireless only is unusual. So determine if 92 homes wireless only is unusual. So if something is unusual, that means it lies outside of the 2 standard deviation range, or out of that 95% range. So real quick, let's just draw and here's our mean, and I'm just going to say plus 1 sigma, plus 2 sigma, plus 3 sigma, minus 1 sigma, minus 2 sigma, minus 3 sigma. So what we care about here is this 95% range. Remember, this is our 95% of observations lie between plus or minus 2 standard deviations. And if you want, we can go ahead and, between plus or minus 1 standard deviation is 68%, then line out here is 99.7. So, but what we care about when we're talking about something, if it's unusual, if it lies outside of this 95% range, or outside of 2 standard deviations. So this is what we care about if it lies outside of there. So what we need to do is populate these values to see where these 92 homes lie. So the mean we just found to be 75, and then the standard deviation is 7.5. So if I come out here to 2 standard deviations, I'm just adding 7.5 plus 7.5. This is 90, and over here minus 2 gives me 60. And then if you want to write in here in the middle, in between, you can. This is 82.5 and 67.5. So what we care about is if this 92 homes, where does it lie? 92 is right here. So yes, it's unusual. So if something lies outside of that plus or minus 2 standard deviation range, we call it unusual. Alright, and that's all I have for now.